Hello, grade 8s. Welcome back to MV Tutors. I'm Tilo and I'll be looking at functions and relationships with you. This is quite important. Everything we've done building up to now has been very critical and important. And this topic, you really need to understand it because going forward with maths, you'll be using functions a lot. And this is a sore thumb for a lot of grade 10s, 11 and 12s when it comes to functions because they still don't understand the basics, and this is what we are covering at this moment. When we talk functions, basically we're looking at the relationship between two variables, all right? In this instant, x and y. So you have one thing called the independent variable and the other called the dependent variable. All right, for example, let's say we look at weather. So weather is independent. We do not determine if it's going to be hot or cold. All right, so if it's very rainy or very cold on that day, you might be tempted to drink coffee or tea with scones or fat cakes. All right, so the drinking of hot coffee or tea is dependent on the weather. So the weather is independent, and whatever you drink that day is dependent on the weather. Okay, so that's the kind of relationship that you must stick with in your mind, in your head as we go on. So before we even get to the functions, let's say in terms of y is equal to x squared or whatever, we're going to look at flow diagrams so that you understand the difference between what you input and the output that you're going to get. So, what is the flow diagram? A flow diagram basically shows you the following: input values, all right? And then there's this box where the rule is given. What do you do with that input? Do you double it? Do you half it? Do you square it? Do you cube it? Okay, and then onto your right, that's where you get the output. For example, let's say you have an input of 10. What do you do with that 10? You add 3 and you add 5. So if you add 3, you're going to get 13, and if you add 5, you're going to get 18. So what is your output? It's that. Okay, if you take 7 as your input and you add 3, you get 10. If you add 5, you'll get 15. All right, and then if you get 13 as your input, if you add 3, it's 16. If you add 5, it's 21. Okay, so flow diagram shows you the input, then you have to apply the rule, and that's how you get the output. Okay, cool. Now let's look at another example. So your input here is basically x. Now we're using a variable. Whenever we use letters or alphabets, that basically tells you it's a variable. It's an unknown. At that point, it's x. We need to solve this x, or we need to find out what x is. And they tell you that in the place of x, you're going to put 5. Okay, so firstly, if we say 5 plus 11, x is 5 in this case, plus 11, you're going to get 16. If you have 12 plus 11, right, if x in this point or in this situation is 12, so you're going to say 12 plus 11 is basically going to be 23. And then if x is 20, we're going to say 20 plus 11. And what would that give us? It will give us 31. Okay, so this is the rule. We take whatever x is at this point in time, whether it's 5 or it's 12 or it's 20, and we just add 11 to it. Okay, that's basically how functions work. Let's look at another example. So let's say in the place of x, we will put 4. All right, so basically if you rewrite it, you put 4 there, plus 4. So what's a half times 4? It's basically 2 plus 4. The answer is 6. So we're going to put the 6 there. And you do it in that same manner. So if we put 16, what's half of 16? Half of 16 is 8. 8 plus 4 is 12. If we put in there 22, all right, half of 22, which is basically 11. Okay, well, let me rather put it on the side. So we have 11 plus 4, which is simply 15. That's exactly what you do. All right, substitute in that value. Like here, we said 5 plus 11, which is 16. Okay, if you need to write it out yourself. All right. And another example. So now we have an input called A. It's a letter, right? We use X, we use A, we use B. They can use L, K, J, anything. Okay. So do not be confused when you start seeing letters and things start becoming blurry. It's just a variable. We just don't know what it is. But in this case, they tell us in the place of A, we now put C. So if you put C in the place of A, it's simply going to be C cubed. All right. And in the place of A, let's put 2D. Okay, this is the input. So we're going to put 2D cubed, right? What is 2 cubed? 2 times 2 times 2. That gives us 8. What is D cubed? It's simply D cubed. So there we are. Put 8D cubed. And then we're going to put in E squared in the place of A. So you can put variables, you can put numbers, it doesn't matter. Okay, so here there are rules. Remember those exponent rules we went through? This is where they come in handy. So we have E there. Now, if you have a power raised to a power, you're simply going to multiply the two. So E squared times 3 is basically going to be E to the power 6. Because you E squared to the power 3, not times 3. E squared to the power 3 is like saying we have E squared there, right? And we're going to multiply it by E squared and multiply it by E squared, all right? And then you have a common base, right? So what do? You add the exponents. And so we have E to the power 6. That's how we get it. Or simply, you just, a power raised to a power, you just multiply the exponents. Okay, that's how you basically sort that out. And now let's have a look at using tables to determine output values, because they can be quite important. Okay, so now it says in exercise 5.1, use the following rules to find the output values for the input values given in the table below. So we have our rule over here. It's 2x plus 5. And then you have an input. So what does that mean? It means in the place of x, we're going to put 4. Okay? So let's do it like this. I'm going to take out the calculator because we will be changing the values as we go. Right now, we're going to put 4. And then next, we're going to put 6 and so forth. So we have 2 times x. And in this case, we're starting with 4. So in the place of x, we put 4 and then plus 5. Okay, 2 times 4 is 8. 8 plus 5 is 13. So that's what we're going to put now. The 13. And now in the place of x, again, we're going to put 6 because that's the next number. Okay, and then we get 17. And now in the place of x again, we're going to put 7 and 9 and 10 and 20. Goodness, this is going to take a little bit of a while, but the more you practice, the better you become. So 2 times 7 is 14 plus 5 should be 19. All right, so I'm just going to go ahead and write down all the answers for the remaining numbers. Okay, so we have 23 there. Let me just take this a bit low. Put this up there so that I don't struggle. All right, then we have 10 there, so that's 25. And then 2 times 20 is 40 plus 5, 45. All right, so that was that. And then secondly, we have 5b squared. Okay, that is your rule. All right, so in the place of b, we're going to put 0. Okay, so if you have 5 times 0 squared, that's basically going to be 0. If you have 1, okay, so 1 squared is 1, multiplied by 5, you get 5. Okay, and then if you have 2, all right, so we know that 2 squared is actually 4, so it's like 5 times 4, and then we have 20. All right, Let me just attend to this little one. And now, if we look at 3, again, all you're going to do is substitute 3 in the value of b. In the place of b. What is in the value of b? Okay, so 5 times 3 squared is basically 9. Alright? So now what is 5 times 9 is 45. So basically that's what we have over there. And then we go on and so forth. Alright, I'm just going to use the calculator now. So what is the rule? The rule is 5 times whatever b is at that point, which is b, and 5 squared. So basically 5 squared is 25 times 5, we get 125. And then we have 9. So what do we do there? Okay, we get the answer 405. And then now the next rule is 4x divided by 2. So in the place of x, we're going to put 5. Alright, so now 4 times 5 is 20, and if we divide by 2, we're going to get 10. Okay, so that's how it goes. The next one, we multiply by 10, divide by 2. So 4 times 10 is 40, divided by 2, that's 20. Alright, and then we have 4 times 15, and 4 times 20 divided by 2, 4 times 25 divided by 2. So let's just put all of that in the calculator, because now you're starting to get the hang of things. Alright, you're starting to understand it better. Alright, so if we put 15 there and we divide by 2, we're going to get 30, because 4 times 15 is 60. And then 4 times 20, that's 80, divided by 2, we're going to get 40. And then 4 times 25 is 100, divided by 2 is 50. Eh? Okay, 4 times 25, yes. I'm thinking ahead of myself. And then 4 times 30 is 120, right? Divided by 2 is 60, yes. Okay, so I think at this point in time, you're really getting the hang of this. Okay, now let's try another one. Let me just see. Yeah, we're almost there. Okay, so we're getting an interesting one. Okay, so your input there, we're going to substitute into y. Firstly, we have 1 in the place of y. Alright, so 2 times 1 is 2. 1 squared is just 1. So our answer there is 3. And if you put 2 now, okay, 2 times 2 is 4, and 2 squared is 4. So basically we have 8. And then we try 3 until we start using the calculator when I feel like you are, confident there. Okay, let's see. So 2 times 3 is 6, and 3 squared is 9, and 6 plus 9 is 15. So there we go. And what happens if we put 4? So basically we have 2 times the variable, the number that we're going to put there, and then we have y squared. So in the place of y, we put 4 and squared. So now we have 24. And then if we put 5, it's basically going to be 35. And then if we put 6, it's basically going to be 48. Okay, now you guys are ready to try this on your own, right? You can definitely do this. This is a nice way of representing a function and the rules to see how we apply them. All right, and next we're going to look at algebraic expressions.